Hey Comets, hope you're doing well. Another video helping you on the packet. So let's get right into it. Today we're going to be looking at this page right here, comparing rates, okay? So says, during the basketball season, Terrell scored a total of 54 points in 9 games. Marvin scored a total of 45 points in 6 games. Determine how many points each player scored per game. Okay, which player scored more points per game? So this kind of comes up with the idea of what we call a unit rate. Okay, a rate is basically a ratio, but it's comparing two different things, like miles and hours, right? Distance and time. A unit rate compares it for one of those things. Okay, so miles per 1 hour. All right, because you could say, yeah, I went 600 miles in 4 hours. All right, but how many miles would that be in 1 hour? That's a unit rate, and that's kind of what we want here, per one game. Okay, so what we're going to do is create a ratio based on what they said, 54 points per 9 games. So that's our ratio, or our rate, if you will. And then they want to convert that to a unit rate per one game. Okay, so what are we doing here? It's a lot like what we've done in the past few days. Instead of scaling up, we're scaling down. And when we scale down, it's kind of hard to see because it's really fine print, but we are going to divide. Okay, that is the dividing sign. So we're going to divide 9 by 9 and get 1. And so then we have to divide 54 by 9, and we would get 6. So our answer is 6 points per game for Terrell. All right, and then Marvin, 45 points per 6 games. Okay, like it says over here. All right, 45 points per 6 games. And we need to divide that 6 by 6 to get 1. All right, so then 45 divided by 6 would be about 7.5 points per game. Okay? So 6 points per one game, 7.5 points per one game. Now, obviously, he's not going to score a half a point in a game. That's impossible, but it's the idea here. Okay, it's the average. All right, so who scored more points per game? Well, we would say that Marvin did, all right, because of our unit rates that we can see here. Once we get things to unit rates, it's really easy to compare because then we just look at who had more, all right? Or if we're looking at price, which is the smaller price per item, okay? So let's take a look at this. Number 1, Cordell is able to complete 14 math problems in 21 minutes. Gabriel is able to complete 6 math problems in 10 minutes. Determine how many problems each student can complete per 1 minute. Okay? And who can complete problems more quickly? So there's 2 questions we need to answer here. First off is how many they can complete per minute. So let's do this. Let's divide our area into 2 things. We're going to put Cordell on this side. Okay? And then Gabriel on this side. And it says that Cordell can do 14 problems, I'm going to abbreviate here, in 21 minutes. Okay? And then it says that Gabriel can do 6 problems in 10 minutes. All right? So all I've done here, I'm going to zoom in so you can see a little bit better. All I've done here is I've just organized the information into ratios, as you can see. Okay, we got 14 problems in 21 minutes and 6 problems in 10 minutes. All right, now the first thing it says is it wants us to find what that would be as a unit rate. If I had a little more room here, I would probably write it over here. So I want to know how many problems can I solve in 1 minute? Okay, are we scaling up or down? Okay, well, we're going down, right? Because from 21 to 1 is scaling down. So I want to divide. So I'm going to divide by 21, which means I need to divide by 21 up here. Now, that may seem weird because we're going to get a number smaller than 1. It's going to be a decimal. All right, no worries. Let's pull up a calculator and let's see what we get. Okay, I wanted to divide 14 by 21, and I get 0.67 if I round. And that's going to be 0.67 problems in 1 minute. Okay? Now, back to this. Now it's 6 problems. 10 minutes. How many will that be? How many would that be in 1 minute? Okay, so let me zoom in a little bit so you can see what I'm doing here. So 6 problems in 10 minutes. What do I need to do to get to 1 minute? Well, I need to scale down. So I'm going to scale down by 10. So in other words, I'm dividing 6 by 10. Okay, that's going to be 0.6. All right? If you don't believe me, you can try it on a calculator. Okay, so basically we're comparing 0.67 problems to 0.6 problems. And we need to decide who solved more problems per 1 minute. Okay, so we're comparing 0.67 versus 0.6, or we could put a 0 there. Which one's bigger, 67 or 60? I'd go with 67. So we would say Cordell, what was that question? Because I want to make sure I'm answering the question being asked. Who can complete problems more quickly? Okay, Cordell can complete problems more quickly. I could have said that in a shorter way. He can complete problems more quickly. And here's why he's quickly, right? Because for the same amount of time, he did more. Okay? That would be my final answer. All right? Cordell can complete problems more quickly. All right. So what do we have left here? Okay, that's pretty much that page. Okay, and as you can see, these basically do the same thing. Okay, compare your two unit rates to get your final answer. Yeah, let's take a look at this very last problem. Okay, how would we do this? Well, we're going to have to do a little work here to find each bag separately, all right? To find the better deal. Okay, so all these bags, we need to figure out how much it costs per pound. Okay, at least that's what I would do. All right, now, not all of these are in pounds though, so this could be a little bit tricky. Let's see what we're going to do here. Okay, I think we can still do it. Okay, I'm going to work on A. All right, it's $4.49 per 5 pounds. B, already done for us. It's 64 cents per 1 pound. Because remember, we want that per one. That's our unit rate. C is $1.35 per 2.3 pounds. D is 98 cents per 1 3/4 pound. And finally, bag E is 0.25 per 3 ounce. Okay, this is going to be interesting. Okay. All right, well, this is what I would do. We want to find out how much it costs per 1 pound. Okay, that's where I would go with it. Okay, so another trick you can do here, you can do scaling up or scaling down, or you can divide the top number by the bottom to find how much it is for 1. All right, so let's do that. Calculator ready? We've got, let's slide this down so you can see what calculations I'm doing. We've got $4.49 divided by 5 pounds. And that works out to be about 90 cents per 1 pound. Okay? We already know B. Let's find C. Now, the cool thing about this is if I divide by 2.3, that's all I need to do. So it's going to be 135 divided by 2.3. And that would equal, whoa, a little bit cheaper. Okay? It's going to be about 59 cents per pound. Okay? So buying more doesn't always save you money. Keep that in mind. All right? Learn that the hard way. Okay? In China, one time I bought a 3-pack of soap thinking it was going to be cheaper than buying 1 bar. Later I was like, wait a second. No. If I buy 3 single bars, it's cheaper than buying a 3-pack. Why? Why did I buy a 3-pack? Because now I can have 3 different kinds of smells, right? Because I didn't know what the smells were. It was in Chinese. I couldn't. So I'd take them all home and figure out which one I liked the better anyway. Sorry. Random story. All right. 0.98 divided by, 1 3/4. 1 3/4 on a calculator. How am I going to type that in? Well, if you think about it, 3/4 is going to be 3/4. And if I have 3/4, it's 75 cents. So I could do that. I could divide that by $1.75 because I had 1 whole, and then the 75 represents the 3/4. So I hit enter, and that is going to be about 56 cents per pound. All right, now what about this one here? Okay, this 3 ounce. Okay, ounces are actually smaller than pounds. Let's see if we've got a conversion table up here, or if this is in that conversion chart. Scroll back up. Uh-oh. Gonna test my knowledge here. You know what? I don't want to steer us wrong, so I'm going to go, hey, look at that, YouTube channel. How many ounces in a pound? Oh, look at that, 16 ounces in 1 pound. All right, so what do I have here? I have 3 ounces. So what fraction of a pound is that? Oop, went too far. Okay, well, 3 ounces would be what fraction? It'd be 3/16. Okay, so what I want to do is figure out how many times do I need to multiply that to get to 16? Okay, Is that going to be the easiest way to do this? I'm thinking divide 3 by 16 first. Bear with me here. Okay, 3 divided by, delete. 3 divided, okay, something's not right. 3 divided by 16. Yeah, that didn't work. Okay, start over. 3 divided by 16 equals 1.8, nope. 0.1875. So what I'm going to do is divide this 25 cents by 1.875, and we're going to see what that equals. Okay, in pounds. So 0.25 divided by 0.1875. That's expensive. Look at that. $1.33 per pound. So in that case, you definitely don't want to buy the small because it would cost less to get the same amount. It's kind of costly. All right, so here's what we've come up with. Okay, you can see we've got 90 cents per pound. We've got 64 cents per pound. We've got 59 cents per pound. We've got 56 cents per pound, and we've got $1.33 per pound. Definitely, there it is, $1.33. Definitely not this one. Definitely not this one. And it's a close race, but I think we would go with D. Buying the 1 3/4, 1 3/4 of a pound for 98 cents is the best buy. Okay? So you heard it first right here. Okay? If If you want to buy sunflower seeds, buy the 1 and 3